viewers. How are you? I'm here to take you in physics, senior 1, through this new curriculum. I'm going to guide you, as you know that we are not entitled to give you the lecture notes, but we need to formulate together. You come out and you present, and I want out. But for this case, you are not with me right now. But if you see this video, you'll be able to formulate your own notes and to move forward. I'm Katerega Muzei, physics teacher, stroke mathematics. So, allow me to take you the chapter. Under this chapter, we are going to talk about temperature measurement. Temperature measurements, you should get to know that we have the keywords there. Keywords there, we're going to talk about the temperature. We are going to talk about also the temperature scale. Also, we are going to talk about the thermometric property. Under this, you get to know this. Also, we are going to talk about upper, fixed, and fixed temperature, and we have lower fixed temperature. Also, we need to talk about also the clinical thermometer, the clinical thermometer. The clinical thermometer. We have under this also we talk about digital and so on. So allow me to go through this, just to guide you. Under this chapter, you'll be able to know what I meant by the definition of temperature. When we talk about temperature measurements, look around first. Now you are at home right now, but look around. Can you estimate the temperature of your room? That is the question. Also, can you estimate the temperature outside your house? Can you estimate the temperature under the tree? Can you? So, if you can estimate that, you are under what we call the temperature measurements. But temperature moves with what we call, when we talk about temperature, the first one, temperature, here we are going to know. You should get to know the temperature and heat. This point 1. It is your task now to know the definition of heat and temperature. If you still remember your primary when you started, we talk about the coldness and hotness. For me, I don't know, but you know very well like there. I don't want to move very fast on this, but the difference, temperature and heat, white and temperature, you should get to know that. Also, under this, when you talk about the measuring of temperature, we are going to talk about also measuring of temperature, measuring of temperature. And here, I'm going to give you a simple task about that. You should get to know how to measure the temperature. Now, can you measure the temperature of your body? Or can you measure now the temperature inside the fridge and get to know? So, use which instruments? You need to get to know the instrument you use. There, you identify the instruments you use to measure that. You'll be able to know how to measure the temperature of your body, the temperature of the fridge inside, the temperature of your room. All that is under what you call measurements. Okay, I pose a question to you. Dear students, my friends, here, how good are you to estimate the temperature? Let me cross this question there. How good are you? How good are you at estimating temperature, estimating temperature, question mark. Can you estimate the temperature? Can you estimate the temperature? The temperature of number one, of a cup of tea. I know that all of you take tea. Also, number two, warm that water. Let us talk about Roman 3. The hot day. Try to estimate. And Roman 4. Grammatically, we cannot leave this. Then Schumann. Body temperature. They try to estimate, remember, from the starting in the chapter 1, when we talk about measurements, we know we talk about the word estimating, and you get to know this word, how to estimate. Here I can estimate. From here I can estimate the temperature of this room, and I say is 23 degrees Celsius. That is the way of estimating. So it is upon you to estimate. You don't use an instrument to estimate. You use an instrument to get the actual temperature. But you are going to estimate. This is your small task there, under measuring the temperature. So we are going to talk about also when we come on the thermometric property there. We are going to talk about the types of thermometers. The types of thermometers. The types of what? Thermometers. You should get to know the different types of thermometers. I cannot give you, we have this, we have this. You are supposed to identify those thermometers you use. And if you want to use to measure the temperature of steam, you are going to use what? Which type of thermometer? If you want to measure the temperature of a body, you are going to use which thermometer? Try to identify the types of thermometer. You need to get to know that. Measuring, we talk about also the liquid and glass thermometer. Liquid and glass thermometer, I can give you one here, and you get to know that if you have liquid in glass thermometer, liquid in glass thermometer. That one is very common. We use in the lab. You find that one in the lab. To identify the most, the rest types of thermometer. Open the books, read, you get to know the types of thermometer. But remember, we started with the measurements. We started with the temperature measurements. We talk about the temperature, but under temperature, we have the heat and the temperature. You just get to know the definition of the heat and the temperature. There must be there. Measuring of temperature. Do you know how to measure temperature? Where is which instrument to measure temperature? You just get to know that. And how are you going to use that instrument to know the temperature? Can you be able to estimate? Can you be able to get the actual one? So, it's going to be there in your task very soon. But just get to, for me, I just try to highlight some. So, when we move on this liquid in glass thermometer, that is one of the type of the thermometer, liquid in glass thermometer. Which liquid is there? Try to identify. If it is water, you give me water. If it is mercury, you give me mercury. If it is alcohol, you try to identify. When you see what Tom try to get more research about that. For me, I'm here to guide you, not to give you each and everything. My target to guide you, I know that you have each and everything. You have the books, so don't remain seated. You just concentrate and find out. So, when you move on this one, try to identify the type, the liquid there they use. And which one is the most one suitable in that liquid in glass thermometer? We use what? We use mercury, we use alcohol, we use whatever. So, you get to know that. When you move on that, you be able also to identify the what you call the degree Celsius and Fahrenheit. You'll be able to know if you try to read and you cover that part of temperature measurements. You'll be able to learn more. You can find also in geography, they talk about that. It is related. So don't just sit down, just get to know that. So, when we talk about, let us move on to clinical thermometer. That one, for me, you just learn about clinical thermometer. Hey, clinical thermometer, just get to know what can use the clinical thermometer, how it works. Since I'm guiding you, you can visit where clinical thermometer works and you interact with that. The doctors, the whatever. I know that there is some clinic there. You just get to know how it works. So that one is also more crucial. Let us talk about the temperature scale. The temperature scale. Under temperature scale, the temperature scale. Here, we are going to talk about the upper fixed point and the lower fixed point. Identify what you call the upper, what you call the lower. If we have liquid in the glass thermometer, this is a simple one. There is a bulb there. There is a mercury thread there. There is a stem. There is what you call upper, and there is what you call lower. Upper and lower. Identify what is at the upper and the lower fixed point. What is at the upper fixed point? When you talk about the upper, what is that? When you talk about the lower fixed point, and the lower fixed point, you should get to know the definition of the upper fixed point and of the lower fixed point. If you get to know that, you will be able to identify the correct one in terms of what you call the temperature scale. You just get to know upper fixed point. When you talk about upper fixed point, the temperature is at what? This temperature of the upper is at what? If we say at 100 degrees Celsius, how are we going to identify that? Fix the point. Now I do that. The moment you see this, you'll be able to get to identify. Remember here, now you are not in the lab at this moment. So, if you want to get the upper fixed point, you get the saucepan. Or else here you can use the beaker. I will use the beaker. But you get the saucepan. This one will beaker. Water. You pour there some water. You pour some water in the saucepan. You boil. For me, I can use heat in the bracket, Bunsen burner. I can use oak stove. If I have, I can use a stove. And we have also the thermometer. The thermometer. Now, to identify this, remember this one, it is your task. It is a small activity. You are going to color out, but this time you are not going to be in the groups, or you can consult your friends using your mobile phones and you call them and you try to connect as a group. So, here, what you do to know the upper fixed point, if you are alone, prepare this. You don't have beaker, use a saucepan. Water you have, a heat, you can use a stove, and a heat that water to boil. Use the thermometer. You can try this more 3 times to get the exact value. If it is constant, you conclude the upper fixed point. What you do, you get a beaker, you pour there some water. We have water. Heating sauce. This is water. Until what we have the thermometer. That is the small thermometer we have. Most likely, we try to this. You need this water to boil. To boil. And you look upon the what? Let me press the thermometer in this format. You look on the mercury threads. You observe that particular thread while you're boiling. Time is going to reach and the material thread stops. Identify. Around the stem, there is a scale. You try to read that scale. You try this one 3 times and you conclude. I know the task is there. We have the activity there, but that is this. How I can guide you? I cannot give each and everything, but just try to guide you in this pandemic time. So, you try to do when you are not there, you will get to know more and more. That is the upper fixed point. When you talk about the lower fixed point, the lower fixed point. Lower fixed point, what you should get to know, since it is lower, here, we use what? Can I refer to use what? To get lower fixed point, lower fixed point must be at 0 degrees Celsius. When it is at 0 degrees Celsius, here, you qualify that this is the lower fixed point. So, there we use what we call the small piece of ice. Small pieces of ice. We have the thermometer. The thermometer, you can use the thermometer. You get the small piece of ice there. You get the thermometer. You also, you can get a beaker. Or then you get a cup. You use a cup. Cup can work here because you are not going to find a beaker, but you can use what you call a cup. A cup. This ice you can tell your dad, your mom, your brother to buy a cup for you. The thermometer, you can address this on the thermometer. If you are in contact with us, you'll be able to get the thermometer. Or nearby, you can use the thermometer. Then, what you do, you try to carry out this one. For the same procedures, you get that beaker or 1 cup, you pack small piece of ice there, you wait to melt, then you insert the thermometer, and you look on the mercury thread. Is it moving up? Is it moving down? There you go. You can record 3 times and you conclude. So that is what you call the lower fixed point. You identify, for me I cannot give you the answer, but you identify. When you press ice layer, when you pack ice layer, try to identify. You are going to get what? So you need to be very, very careful about that. Another thing, we are going to talk about the also the calibration. The calibration of a thermometer. Calibration of a thermometer. Calibration of thermometer. Here we talk about the upper and the lower fixed temperature. The upper and the lower fixed temperature, how are we going to combine the two? That's why here you need to get to know when you make your own research, you'll find that in the calibration, we talk about the lower fixed temperature. And here, what do you have? There is a filter fan. You pack there the ice. Small piece of ice, you insert the what you call the thermometer. And you see the example of the steps carried out. There is a beaker here. I can press the beaker down to collect the water. Oh. Before inserting the thermometer there, before inserting this thermometer, you first wait the ice to melt, and you insert. You observe. The time is going to reach when this mercury thread is constant. That is what we call the lower fixed temperature. So that's why we talk about when we talk about the lower fixed temperature, you come out with this. See, at 0 degrees Celsius, this is what you call the low fixed temperature. That temperature, it is at 0 degrees Celsius. So, we'll be able to identify when you talk about at 0 degrees Celsius, the mercury thread, the mercury thread is at 0 degrees Celsius, and this one is denoted, and this is equivalent to, and this is equal to L naught. That L naught is the mercury thread at 0 degrees Celsius. So, also, what we do again, you'll be able to identify, to find out. This one, the calibration must be a combination of lower fixed temperature and the upper fixed temperature, where we are going to talk about also this one, the upper fixed temperature. You'll be able to know this one. How? See here, when you try to make your own research more, you'll find this. You'll find a lovely flask and that tube which is out, delivery tube, and some water here. Heat. Now the flask is heated. And this one we have the thermometer. When you start eating, what happens? You observe the mercury threads. But here, you need to even, since you are making your own notes, design in such a way that there must be procedures taking. This one, we do like this. This one, we do like that. This one, we do like this. This one. Now what we do after here, we transfer this mercury. This is thermometer. We transfer this thermometer from the small piece of ice when this thermometer is at 0 degrees Celsius, and we call what we insert into a laboratory flask. And we started boiling. What happened when we started boiling? The steam The water is going to boil and the steam. The temperature here is going to increase. You observe the mercury thread there. It will run to a certain point. For me, I don't know, but you get to know when you try to find out. It will run at a certain point at what you call the upper fixed point. Upper fixed temperature point. At 100 degrees Celsius. We know. From that, we know the temperature of the boiling water, but you try to identify the temperature of the boiling water. You'll be able to identify, if you identify that the temperature of the boiling water is what you call the upper fixed point. But you just get to identify that when you have the temperature, boil that water, press the temperature, identify. You'll be able to know. So, with that, you'll be able to get to know the mercury thread at 100 degrees Celsius is equivalent to what? The mercury thread at 100 degrees Celsius is equivalent to what? The mercury thread L100. L100 is equivalent to the length of what? Of mercury thread. Mercury thread at 100 degrees Celsius. That is L know that. And you should get to know there is a difference between the upper and the lower. What is that? Identify that. What is the difference between the upper and the lower? It is what does to identify that. You get to know. So, it is a small question. Example, we are going to try to go with you, and from there, we are going to talk about the relationship between the Celsius scale and the Kelvin scale. We complete that scenario. So, we have a small example here. We are going to try with you, and you will get to know more when you find up close about this. Example, we have, let me look for example here. We have, okay, it goes like this. We have the example there. A mercury thermometer is calibrated by immersing it in pure melting ice. If you try to recall, you get to know that. And then in steam, and then in what? Steam, and then in steam. Above boiling pure water, if if the mercury column, mercury columns are at 60 centimeters, and 16 centimeters, 60 centimeters and 16 centimeters respectively. So, find the temperature. When the thermometer, when the mercury column is 80 centimeters long. You want to find the temperature. Through that, they pose a question in that format. A mercury thermometer is calculated by inserting it in the pure melting ice, and then in steam above the boiling pure water. If the mercury column are at this one and that, respectively, find the temperature when the mercury column is at that. So, my dear students, you should get to know. Don't panic, but try to summarize the given information. You will be able to calculate this task which is given out. You calculate the task given out. If you identify on your own this, you get to know the formula that you can use. There, in our solution, we apply that theta. We know we have the thermometer. This is the thermometer. They talk about the upper. This is the lower. L naught at 0 degrees Celsius is equivalent to 6 centimeters. We have the upper. L100 is equivalent to 16 centimeters. And we have L theta, because L theta is the temperature of the mercury column in liquid glass thermometer, which is equivalent to what? To 8 centimeters. Then, what do they want to calculate? Find the temperature when the mercury then is at that. So, what do we do there? We say theta is equal to L100. We begin with this one, pure, steam minus L naught. divided by L, 100. L theta, this is L theta, sorry about that. L 100 minus L naught times 100 degrees Celsius. That is the simplest formula we can use. We have very many, but we can apply that. There is another one. Another one is very simple. Here, this theta is the temperature which we need. So, here we can say L theta, L at that temperature is, length at that temperature is 8 minus length at 0 degrees Celsius is 6 divided by length at 1 degree Celsius is 16 minus 6 times 100 degrees Celsius. What you do here, I know that you can subtract, you can divide, and you multiply and get the answer. But let us try together. Here, when you subtract, automatically you get what? A2. Divided by, when you subtract here, automatically you get what? 10 times 100 degrees Celsius. What you do, you can cancel by 10 here, 1 by 10, 10. Automatically, when you try to cancel this, in fact, you don't try to cancel, but you just identify. By a 0 is a 0. When you multiply there, you are going to have 2 times 10. When you try to cancel this and that, you get 10. We have 2 times 10. You get 20 degrees Celsius. This is the temperature. You put your conclusion this time. The temperature when the material thread column is this. Is what? That. Don't use this one theta because it's not given. They don't ask you to find the theta. So that is a small example they can try to pose you in there. If you try to identify on your own, you make your own research, you get more and more. So, you need to take care about that. Not everything we can going to give out. We are trying to summarize it. So, lastly, we talk about the relationship between Celsius. This one is going to be the last one on this one. And I give you the active dot integration. I know that it's going to be suitable for you. You must go with this active dot integration and you try to. We have between Celsius scale. Celsius scale, which formula you can use there? The simplest. There, you apply, you identify more formulas, but for me, you can use T is equal to theta plus 27 degrees. This one, yeah, is like that. Where T is temperature, this is the Kelvin scale. Kelvin scale, and theta degrees Celsius scale over degrees Celsius, degrees Celsius. Oh, okay. That's in that form. This T, let us talk about the temperature. Temperature. In Kelvin. In Kelvin. Identify the symbol of Kelvin. Identify the symbol of Kelvin. Identify the symbol of degrees Celsius. Degrees Celsius. That's simple. So, if you know this C2, you'll be able to distinguish between, to get the relationship between Celsius scale and Kelvin scale. We are going to write for some 201 examples under that Celsius scale and the Kelvin scale. Example 1, convert the following, to shall we Celsius scale. Celsius scale. We are going to convert the following Celsius scale, but how? Woman 1. degrees Celsius. 2. Because we are going to convert the following to Celsius scale. This one is in Kelvin, so we are going to convert to Celsius. We have Roman 3, Roman 2. We have 250 Kelvin, and Roman 3, we have 720 Kelvin. We are going to convert from Kelvin scale to Celsius scale. So this one, don't think a lot. Even you can calculate. Was that about that formula? You apply that formula. Now here, at first, if I try 1, even in verse 1, you try the rest. We have in our solution, our T, capital T, is 27 Kelvin. We have, they want to find theta, and we have the formula from theta is equal to T is equal to theta plus 27. If we substitute this in this formula, we are going to get the answer. How? And here I have 270 is equal to theta plus 273. If we try to now, we are going to do what? To collect like terms now. Here. When you collect like terms, like subtracting. Our theta alone will be equivalent to 273 minus 273. And automatically, you're going to get 0 degree solutions. So, I think you can try 8 and 11 things. If you have that, you can try the rest. There are some activity there. If you come across any activity, try to color that activity. You're not going to color that activity with you, but you need to be alone and you color the activity. Go about the solution scale and the average scale. To calculate. Those are small calculation which is there in the H measured in temperature measurements. That is chapter 5? Yeah, chapter 5 there. If you look on there's a book of yours, is chapter 5, but that one is very little. Was about that, you need to sit down, you concentrate a lot. You formulate your own notes through this. If you are able to come across, there are some small exercises there. You do those exercises, you will gain a lot, and you look for some more examples and more exercises are there. You learn. When you are alone, you get to know more. You can even consult your elders. They are there, senior 3, senior 4, senior 5, and senior 6. They get to know this. Even your dad, your mom, they can get to know this because they move through this. So, that is the little I can give, I can share with you, I can try to guide with you. So, be in position, you are going to sit down, you concentrate a lot, and you formulate your own notes. When you are now with your dad and with your mom, this time you're not going to be with your teacher, but you need to sit. Then you're dining, you formulate this notes when you are alone. That's a small question I can try to talk. If you have this, you gain more. This is just like a guideline that we are going to sit there. We are going to look on this one. We are just guiding you so that you formulate and not so concerned about this. And last we are going to have the activity of integration. That one you can do and you can send, we can mark, and so on. Since we don't have that time to be with you, but there is activity of integration. Think about this activity of integration. Let me give out this activity of integration. You'll be able to get to know more and more. We have the activity of integration. This one, you sit and think about this activity of integration when you are there. They say that